Hello everyone, welcome to the channel Computer Science Interviews. Here we discuss frequently asked questions in computer science interviews, and today's topic is assert. So the question that interviewer can ask is explain the use of assert in C, C++, or it can be phrased in any other way like how assert works, give an example of use of assert. All these kind of question we are going to address today. So, as it is, you can see in the screen, it is mentioned in the explanation that assert is a preprocessor macro directive, which is ideally used for debugging purposes. Its syntax you can see on the screen. You can call assert as a function call. However, assert is actually preprocessor macro, which is defined in assert.h header file, and you have to include this header file in your program if you want to use it. Now what assert do is assert basically checks for the condition that is passed into it, and if the condition is true then program follows its normal execution path. However, if the condition is not true, then the program will abort at that point, and it will print a debugging information at that point that why it has failed. It will tell you which assert condition it has failed. Some advanced compiler will also print line number and the file name when the assert fails. Advantage of assert with compared to normal condition based checking, like if you can use if else or some other way of checking the conditions. However, assert has some advantage over that. The advantage is that if you define a macro hash define and debug before you include assert.h. So basically you can define this macro at the first file line of your file, and then you can include assert.h. So what happens is whenever you define this and debug macro, all the asserts call will be ignored by the compiler. So how it is used in actual development environment is that during the debugging phase, during the internal releases of software development, during the development phase of any large softwares, mostly this is used during for system programming and all these places. What happens is during the development phase they do not define this hash define and debug macro. So what will happen is all these assets call will be evaluated during the runtime, and compiler will compile this at the runtime. The program will execute all these condition checks. So whenever there is any condition failure, the program will terminate at that point, and developer can debug it at that point that why the condition has failed. When you want to release your software product to actual end users, what you do is you define this macro. Now, whenever you compile a program with this macro defined before you include assert.h in your program, the compiler will simply ignore all the asserts call. So the overhead of checking the condition will not be imposed in the release version of the product. Although those changes might not be, although the improvement in the performance might not be that much great, but it is critical in the case of system programming where performance is a key aspect. So this is all. This is mostly all about assert. You can get more information on assert at this website. I'll put the link to this website into the description. You can find all the detailed information. Now let us understand assert with examples. So assert is used mostly in three different ways: to check preconditions, to check post conditions, and third is to check condition in between, which is called invariants. Now, this is the example of preconditions. So whenever you implement a subroutine, you expect certain values to be passed into that subroutine. Now, if these values are out of their limits or are not coming as you would expect to come, what will happen is your developed function will misbehave. So to avoid that, we can add a if else base or any other kind of condition checking which will add overhead to the execution, and it will also take a lot of development effort. What we can do is, and what most development purpose they use is they use assets. So here is an example. So this is our main function. It defines two variable a and b, and it passes these two variable into a function called my function. Now my function will receives these two values. It expects it to be within their own limits. So A's limit is, let's assume, is 100, and let's assume B's limit is, maximum limit is 200. Now if these values are out of those limit, this function might misbehave because it handles those values in such a way. So assert will make sure that these values are in their limit. So how we can achieve that? So you can see that we are calling assert. We will say a is less than or equal to a's max limit. So this is a condition which will ultimately result in either true or false. In the case where this is false, program will terminate at this point and it will print this condition along with the line number and the file name, so that the developer can debug that why it is failing here. Something must be going wrong, which can be fixed at the development phase. Now when this program is to be released for a general public, we can define and debug macro at this point. So if that macro is defined here, then all these asserts call will be ignored by compiler. They will not be part of the final release. So at the development phase, at the debugging phase, you are checking all the condition, but at the release time, all this overhead of checking the condition is ignored, and you will achieve a slight performance improvement. However, it will be critical if it is a program like kernel or system programming, where performance is a very key aspect. If these conditions are met successfully, then all these assert will not terminate the program, and program will reach to this line which will say c equal to a plus b, and it will simply return the value of c, which this program will print at this point. So let's see this program in execution. Let's compile the code and let's execute. You can see that since we are passing value of a and b as 120, since those both are within their limits, the program successfully executes. However, let's try to change the values. If we pass 250, which is out of b's limit, let's compile the code and let's execute it again. You can see that it prints main line number 13, my function, assertion b less than or equal to 20 failed, which is this line. So now you can debug that if this happens in real-time environment, you can see why it is failing. You can debug at this point. Now let's see one more example checking. There is one more place where we can use this, that is post condition. So let's check one more example of post conditions. Here this is the same program as before. However, in this case, my function will take two arguments as input. It will produce a third variable, and it will return that third variable. However, before returning this third variable, we want to make sure that post conditions are met. So what we can do is we can put an assert on the final variable. Now the final variable's limit is 255. So if the value of c does not meet its maximum limit, the program will terminate at this point, and it will tell that this is the condition where it is failing. So before passing this value to the next uh, execution part of the program or to the calling function, it is a good thing to check for post condition, so that if it fails, we'll know the exact place where the program, your bigger program, failed. So let's see this program in execution. You can see that we are passing 120, which is in good limits. So you can see that program has compiled, program executed, prints the value of c. Now value of c is maximum to 255. If I pass 200 here, which means a's limit is satisfied, which is 100. If I pass b equal to 200, which means b's limit is satisfied, which is 200. So these two assert will not result in any failure. It will pass there. However, this one will fail. Let's see it. Compile and execute. You can see that it says main.c line number 18, my function assertion c less than or equal to 255 failed, which is this line. So this is a good debugging tool. It can help you a lot. It can save a development time. It can be asked in the interviews. You can answer, you can explain all this, you can show this example. It should be sufficient. And for more information, please go through this page. Thank you. I'll see you in the next one. If you like this video or if you like this channel, please subscribe, like. Thank you.